Welcome back to class. Let's return back to the diagram I've been working with. So we just talked about carbon dioxide and allergenic plants, and now I'm going to come back to this side and talk about warming and floods and droughts and their effects on other forms of air pollution. So again, increased energy in the Earth's atmosphere affecting warming, floods and droughts, and sea level rise. Here are the primary health effects. And now we're going to turn to heart and lung disease as affected by all of these effects upon air quality. So just to reiterate, when you look at the climate history that we have, the last decade, 2000 to 2010, represents some of the warmest years on record. So the only year to eke into the top 10 was 1998. And this, by the way, just extends the record further. But 2010 is still today the warmest year ever recorded on the planet. And it was particularly warm in Russia. So you're getting well familiar with these temperature anomaly graphs by now. And you can see here that the temperature anomaly was about 12 degrees Celsius for a huge part of Eastern Europe and Russia. And this is the temperature anomaly compared to a baseline of 2000 to 2008. Now remember that 2000 to 2008 was very, very warm compared to all the other years. So using that baseline and stating that there's a 12 degrees Celsius anomaly over the period of a week is a quite profound extreme in heat. So one of the questions that came up in this extreme heat wave in Russia in 2010 and Europe was climate change causing it, or was this caused by natural forces? And there was some scientific research that suggested that what triggered the heat wave was a well-described event that occurs over Northern Europe that involves high pressure sort of settling in over Northern Europe, called a high pressure block upon the circulation of air, and that when this high pressure settles in, it creates essentially heat waves, and this has happened in the past. So there is a part of this that is something that is natural, but that doesn't explain the whole story. So I'm going to use this analogy, which I got from Michael Oppenheimer at Princeton, to describe why it is that even though the trigger for this heat wave might have been something that happened in the past, that the intensity of the heat wave itself, in fact, does relate to the greenhouse gas warming we've seen. So imagine you're a person who's dribbling a basketball up a hill. You dribble all the way up that hill, and you're now at a much higher place. So even though the mountain you're dribbling up and down hasn't changed, the level of your basketball has by this amount. Well, this is analogous to what happened in the summer heat wave of 2010 in Russia. The height of the basketball being dribbled is natural variability in the climate system, and the increase in the ramp here reflects the fact that heat waves happen all the time. There's natural variability, but that natural variability is now sitting on top of a much higher average temperature. So while the direct cause might have been something that happens naturally, that natural variability is now occurring on a temperature base that's much higher. And you've seen graphs similar to this before for the heat wave of 2003, but here's 2010 in Moscow, and this compares June, July, and August temperatures since 1950. And you can see that 2010 is way off at the edge of the distribution. The baseline here is 1970 to 2000. One of the consequences of this heat wave was hundreds of forest fires. And there were about 24.7 million acres, 10 million hectares that burned in these fires. And the smoke, if it occurred in the United States, would have stretched from San Francisco to Chicago. And this is a satellite photo that just shows you the extensive scope of the smoke. And these, you can see some of the fires individually here. And this is what it looked like on the ground in Moscow. So this is the same intersection on a normal day and during this set of fires. Now the fires were triggered in part by the extreme heat and because of an extreme drought, which we'll talk about. What's present in the smoke of forest fires? Lots of things that are bad for your health. Acrolein is a lung irritant. Benzene and polyaromatic hydrocarbons, PAHs, can cause cancer. Carbon monoxide breathed at high concentrations can be very harmful. Formaldehyde, also an irritant to the lung. But the one I want to focus on most is particulate matter of 2.5 microns in diameter or less. What is particulate matter, you ask? A good question. So particulate matter refers to anything that's suspended in air of a certain size. So these can be combustion particles, organic compounds, metals, and other things, and they're defined by their size. So a human hair is about 50 to 70 micrometers or microns in diameter. So here's fine beach sand just for comparison. Fine beach sand bigger than a human hair. There's particulate matter that's 10 microns in size or smaller. That's about the size of dust, pollen, and mold. So this is a quarter the size of that. So you could fit about 1, 2, 3, 4, 5 across a human hair of PM10, and then the PM2.5 is a quarter the size of PM10. Why does size matter in the case of air particles? It matters for one reason, in that it penetrates, the smaller the particle, the more deeply it penetrates into the lung, which is pictured here. So you've got blue, green, and red corresponding to 3 levels of nasorespiratory tract. And you can see here that as the particle diameter goes small, it penetrates more deeply into the lungs. And the deeper into the lungs, the more hazardous these particles become. In the case of the smallest particles, the PM2.5, they're actually small enough to get into the circulatory system. And research done here at the Harvard School of Public Health has shown that particulate matter, particularly less than 2.5 microns in diameter, is a major contributor to mortality. And that's what this graph shows, is that as the concentration of particulate matter 2.5 goes up, there's an increase in death. So this is a big deal. And when you burn forests, they produce PM2.5. I want to look at another heat wave and another set of forest fires that occurred in the United States to make another point about the confluence of heat waves, droughts, and climate change, and the risks of exposure to particulate matter in particular. So this is a heat wave from summer of 2012, temperature anomalies on the bottom, and this is a baseline of 2000 to 2011, and you can see here that it was extremely hot in the summer of 2012 over a large part of the United States. It was the hottest year on record in Colorado, and it was also one of the driest. So this is the Palmer Drought Index, and the Drought Index is a measure of both the moisture of the soil and the heat around, and you can see that extreme drought here is prevalent over large parts of Colorado and Wyoming. So you have a combination of extreme heat and drought, just as was the case with Russia, and there were major fires. This is a picture, actually, I believe, from Montana during that heat wave and drought. And this is a picture that was captured by a satellite of the aerosol. So as the forests combust, they release particles in the atmosphere that can be seen from space. And you'll see here that over large parts of Colorado and southern Wyoming, there's a relatively high amount of aerosol put into the atmosphere during, in this case, June 26th. And this is what it looked like from space. You can see all the smoke in the air. These fires burned 600 homes, about 200,000 acres, and cost $500 million in damages. This is a paper that was published not in relation to those heat waves, but in wildfires that occurred in Southern California in 2003, and looked at asthma hospitalizations associated with a 10 milligram per meter cubed increase in the PM2.5 concentration. So it's just asking, when these forest fires occurs, can it affect rates of hospitalization? And there were 2 populations that were dramatically affected in this study, people between 65 and 99. There was a 10% increase, and for children between 0 and 4, there was an 8% increase. So again, the heat and drought contributing to fires puts particulate matter in the air, and that contributes to healthcare costs. But there's another wrinkle to the story of the fires in the western United States, and that relates to this guy, which is the mountain pine beetle. These beetles are able to kill pine trees by essentially disarming them, by infecting them with a fungus that they carry around with them, and the fungus essentially prevents the trees from releasing sap that would otherwise be a deterrent for the beetle's spread, the sap essentially sticking them to the trees. So the fungus prevents that. The beetles then bore into the trees, and the trees can be dead within a matter of weeks. And you can see here the range of the bark beetle epidemic 2002 to 2011, expanding over a large swath of the western United States. And this is what large stands of trees that have been affected, these trees in a reddish brown, have all been killed by these beetles. One of the things that has occurred as the climate has warmed is that the beetles, which historically have only had one reproductive cycle per summer, are now having 2 reproductive cycles per summer. And this is the temperature coded here by month. And you can see that the duration of period of time that it's warm enough for these beetles to survive has increased as well. Not only has the number of reproductive cycles increased, but again, this slide showing that the daily temperature range has fallen and nighttime minimums, which is really the brake that can be applied to insect movement because they're cold-blooded and cold temperatures are what keep them in check. The minimum temperatures have been rising much faster than maximum temperatures with climate change. So that has released the brake that can control the populations of insects. So in the case of the mountain bark beetle, climate change has enabled its ability to thrive by warming temperatures, increasing the number of reproductive cycles. That has left large stands of dead wood, which in the context of heat and drought makes very productive conditions for wildfires. Scientists have done modeling studies asking how climate change will affect the likelihood of forest fires going further across the planet, and that's what's pictured in this slide. And you can see that there are significant increases in many parts of the world in the risks. These kinds of studies, of course, have to be qualified by asking how much warming are we talking about. This study suggested that used an A2 scenario, so a scenario in which temperatures warm by potentially 4 degrees or more Celsius, so a circumstance in which relatively little is done to curb carbon dioxide emissions. But it is clear that a lot is at stake for forest fires, and not just forest fires, but of course potentially fires on crops and homes and elsewhere, given warming and the likelihood of drought. I think it's also important to mention that even today we have a tremendous amount of morbidity and mortality related to urban air pollution, which is what's pictured here. This is a map of urban air pollution and disability-adjusted life years, which is a measure of harm that is incurred by urban air pollution around the world by country and per 1,000 population. So as you can see, that if we have increased wildfires in places in the world where that's likely to happen, that's on top of the issue of dealing with urban air pollution as already exists. So as in the case with the urban heat island effect and climate change and those two things acting together to make matters more difficult, here we have an instance in which there's urban air pollution related to industrial activities and other matters combined with the potential for air pollution related to forest fires. And you'll remember that in the Moscow or the Russian heat wave, the forest fire smoke had an enormous geographic distribution. So these are not small-scale fires. And again, it makes the case that we have a tremendous amount at stake for our health when it comes to addressing climate change, in this case relating to particulate matter and the known effects of particulate matter upon our health. So that's our tour of air quality and the consequences for air quality and our health that relate to increased greenhouse gas emissions. And I look forward to exploring some other pathways that climate change matters to our health next time. I'll see you then.